Okay. Right. Just going to restart that very quickly. Brilliant. Now we'll get started with the interpretation of the derivative. Practice problems. For problems 1 and 2, use the graph of the function f of x. Estimate the value of f prime of a for the given values of a. All right. So I'll just title this interpretation of the derivative. Estimating the value of f prime of a for a equals -2. Okay, so it appears to be sloping downwards at, yes, I would say -1. So my estimate for f prime of -2 is -1. For a equals 3, hold on just a minute now. I think I can do a better estimate than that, what I just said. Keeping in mind that these are not like similarly spaced. All right, so at a equals 3, if I imagine a straight line connecting that point there to that point there, then the change in the y-axis is 2, and the change in the x-axis is 1. So it's actually closer to 2 over 1, which is 2. So f prime of 3 is close to 2, whereas f prime of -2, right, if I draw a line sort of mentally connecting this up here, it's actually somewhat close to, let's say, -5. -5. All right, so I'll check and see if my estimation is reasonable. Okay, so they've said -4 instead of -5, and they've said 2. Okay, as these are estimates, it's not so bad, but f prime of 1, f prime of 1. Okay, as you can see, it connects the tangent line at the graph at this point right here appears to connect from there to there. So I would say 2. I would say 2. F prime of 1 is approximately 2. Whereas for 4, the tangent line appears to go sort of like halfway there up to 3. So I would say it's approximately 6 over 3 over a half, which is 6. That's my estimation. Okay. Okay, they believe it's closer to 1. Oh, right. Okay. I see why that is. Yes. To be fair to them, yes, that really is closer to 1. Change in 2 in the y-axis and a change in 2 in the x-axis. Let's just redo 4 then. Okay, I do believe that I'm right about 4, but we're about to see. Okay, so they've said 5. I would have said 6, but these are just estimates, so there you go. All right. Now, For problems 3 and 4, sketch the graph of a function that satisfies the given conditions. So we are to sketch the graph of a function where f of 1 is 3, f prime of 1 is 1, f of 4 is 5, and f prime of 4 is -2. So what we're going to do is we're going to open up GeoGebra and extract a portion of the xy plane to draw a graph on. And we only need the first quadrant for this, where it's all positive. That's all we need for this. And we need f of 1 and f of 4. Okay, the max is 5. That's the highest quantity involved. So I'm going to grab this much and make my function on here. So f of 1 is 3, so I'll make a point there. That's an actual existing point on the function. F of 4 is 5, so I'll make a point there. And f prime of 1 is 1, so the tangent to the function, there's a sort of mini tangent to the function in the form of a line segment there. And f prime of 4 is -2. So there's a mini tangent of the function there. And so all we have to do is make a function that passes through those 2 points and arguably and reasonably has these sorts of tangents there. So the easiest way to do that is to actually just simply construct a piecewise function. That's the most straightforward way to do it to guarantee that you get what you want. Now it's tempting to go straight across there, but that's not advised actually. So what you can do is just connect it directly to there and then downwards there like that. So that's a piecewise function that has all those properties, not approximately, but exactly. All right, so they've gone through the same thought process as I did. And there you go. They decided to make a continuous looking one that did it. Okay, so in problem 4, all right, so these are the quantities involved. So none of them sort of exceed 8 in magnitude at all. So I'm going to grab this portion, extract this portion of the xy plane. Now, let's obtain, or let's plot rather, the function points which we know to lie on the actual function. Oh, darn it. Look at that, f of -3. Okay, I didn't quite think that through. Okay, so we're going to have to get a different portion. Let's just go for this much. -5 to 5. And that should be quite sufficient. Okay, so f of -3 is 5. So that's where the actual point on the function will go. F of 1 is 2, so that's where that will go. and f of 4 is -2. And that's where that will go. Now, as for the gradients, at -3, the tangent has a slope of -2. So there you go. And at 1, the tangent has a slope of 0. It's flat. And at 4, the tangent has a slope of -3. So that there is perfectly sufficient. And now we just need to make a line, a function rather, which passes through those points and reasonably has those tangents. So here, because the gradient is completely flat, I'm going to make a local maximum like that. And I'll do that. And I'll do that. That's just a continuous function which has those properties. And there you go. There you go. Okay, for problems 5 and 6, the graph of a function f of x is given. Use this to sketch the graph of the derivative f prime of x. So what we'll do is we'll grab the graph itself and put the derivative on that graph. Now, in constructing f prime of x, or something that appears similar to f prime of x, we want to look for important points on this graph, like there, there, and there. That's where the derivative is 0. And so let's see. What should we do? Okay, we'll do red for the actual function itself. So that point there, there, and there. And blue for the derivative. So there, there, and there. Good. Now, of course, I've just realized that it actually has a negative derivative for quite a big significant portion. So what I'll do is I'll just extend the y-axis downwards like that, and do this. Like that. Okay, and from there to there, think about this. So the change in the y value is 5 from, let's say, A to B. Change in the y value is 5, and the change in the x value is 3, and it's negative slope, so -5/3, -5/3. So -5/3, which is -1 2/3, -1 2/3, and so what's the story with this? It'll sort of look like that between A and B, something a little bit like that. And then from B to C, the change in the y value is 10.5, and the change in the x value is 4. So 10.5 over 4, which makes, let's say, a little bit over 2.5. Like that. And then from here to here, that's the change in the y coordinate in the y value of 3, and a change in the x value of 1. So 3 it is. There, like that. And from here to here, that's about negative 3.5. So something there like that-ish. All right, so that's pretty much on track, except they have a much higher value here. It's interesting. Okay, because they've estimated a, yeah, I mean, it just really has to have this general shape. They may have had a higher estimate for the derivative at some points, but hold on just a minute now. 10 versus 4. Okay, all right, so fine. Yeah, it would actually be higher than that point there, as that's kind of like the average. So it would actually really be higher if I think about it. Not sure how much higher, but it would be higher. Likewise, down here, it would actually be a little bit lower than the average if I think about it straight. Yeah, that's good. Okay, next up, similar problem. For problem 6. So what we'll do is extend the y-axis and just by eye something like that. And let's think, what's the gradient of this portion? It's a piecewise function, 3 linear pieces glued together. What's the gradient of this portion right here? It appears to just simply be -1. -1. Like that. And for this portion here, 2 over 3, which is 2/3. And for this portion here, -4 over 2, which is -1/2. Or rather, actually, it's -2. Beg your pardon. There, like that. And the real important thing is what happens here? What happens here? Well, there you get a discontinuity in the derivative because it doesn't have a well-defined derivative there. So it should be like that. It should be like that. I really do hope, though, that he's not going to say that for no reason at all it's actually 0, right? But I think it's discontinuity there. So here we'll see. Good. All right. Now, let's answer the following questions about the function w of z, which is defined as 4z squared take 9z. Is the function increasing or decreasing at z equals -1? So we have to take the derivative, find w prime of z, and that is just 8z minus 9, and w prime of -1 is -8 take 9, which is -17. And as w prime of -1 is less than 0, it's decreasing. Then here, w prime of 2 would be 16 minus 9, which is 7. And as w prime of 2 is greater than 0, it's increasing. And by it, I mean w. For part C, does the function ever stop changing? If yes, at what values of z does the function stop changing? So this would be where 8z minus 9 is equal to 0, where z would obviously be 9/8. Stop changing. Good. Now, what is the equation of the tangent line to this function at x equals 8? So we find f prime of x, and we get that it's -14. So we know for the tangent line, m is -14. Oh, right. I meant to input f of 8. So that would be 112, and 3 minus 112 is minus 109. And 8 comma minus 109. Or lies on it. That's the sort of like formal way to work through it. But as you can see, the function is 3 minus 14x, and the tangent line is obviously exactly the same, right? And that just makes sense. The tangent to a line at any the tangent line to a line at any point on that line is equal to the line itself. It's coincident with it. So I didn't need to do all this work, but I was just showing you that formally the process works out and exactly aligns with our intuition. Now, the position of an object at any time t is given by this function here. S usually stands for displacement in physics. So where we are to determine the velocity of the object at any time t. So but they wouldn't ask that, would they? Are they really asking me to take a derivative of this using the quotient rule? But we haven't moved on to that yet. So odd. Unless I'm just not thinking right. How unusual. Are they asking me to take the derivative of it? I could do that, but we haven't touched on that topic yet. So am I just overthinking it or what? Let's just quickly glance and make sure. Okay. Like, use the definition of the derivative for that. Okay, so practically speaking, no one does that. And of course, it involves all this extensive amount of work and writing out of h just to cancel everything in the end anyway. But nonetheless, try your best. So cleaning up the numerator here, add 1. So you can expand all that out. So we'll end up with t squared plus 4t plus th plus 4h plus t plus 4. Take t squared, take t squared, take t. Take t squared, take t. Take th, take h. Take 4t, take 4. Okay, and then these cancel. That cancels that. That cancels that. And we end up with 4h minus h. T squared plus 4t plus 8 plus th plus 4h plus 4t plus 16. And 4h minus h on the top. And then down here, yeah, we'll have oh, just beg your pardon, that's just 3h. All right, so, I mean, so what? Guess I'm kind of stuck here. Did I do it right? We'll have to see. Oh, that's way simpler. That's way, way, way simpler. And it's an 8t, so the fact that I didn't see that. No, eliminate that. That's wrong thinking. And there's obviously 3h. But then right, okay. Where are you getting this 1 over h business from? Oh, from up there. Oh my goodness me. This is why you carry the denominator the whole way through. Right. Good. I get it now. S prime of t is the limit as h approaches 0 of 1 over h outside the brackets 3h over t add h add 4 times t add 4 inside the brackets, and that is the limit as h approaches 0 of 3 over t plus h plus 4 over that, which is 3 over t add 4 squared. So I get it now. Now, as for the object ceasing to move, it would move when that's equal to 0. And is that equal to 0? So no. It doesn't stop moving. Yes, it never stops moving. Okay. Problem 9. What is the equation of the tangent line to f of x equals 5 over x at x equals a half? Whoops, I meant to say problem 10. Okay, so f of x is 5 over x. So f of x is 5x to the negative 1. So f prime of x is negative 5x to the negative 2, or if you like, negative 5 over x squared. And f prime of a half, well, let's see. We would have to square a half, which is a quarter. And what's 5 divided by a quarter? That's 20. So this would be negative 20. And as for f of a half, to obtain the y coordinate, well, that would be 5 over a half, which is 10. So for the tangent line, we know that m is negative 20 and a half comma 10 lies on it. Those are our two facts. So we're just going to use y minus y1 equals m times x minus x1. So we're going to say y minus 10 equals negative 20 times x minus a half, like that. Now, we're going to expand out on the right, sorry. So we get minus 20x there. Minus 20 times minus a half is plus 10. So I could write a plus 10 here, but I know that I'm going to be adding 10 to it anyway to get rid of that. So I'm going to write plus 20. And I think that's it. So now we check. Excellent. 20 minus 20x. Great. Okay, determine where, if anywhere, the cubic function g of x equals x cubed minus 2x squared plus x minus 1 stops changing. So what we need to do is take the derivative. Find g prime of x, which is 3x squared minus 4x plus 1. Then solve that quadratic equaling 0. Solve it. So I don't know if it factors. Let's just see. And there you go. So at negative 1/3 and 1, g prime of x will be 0. In other words, where the function stops changing. Okay, so we'll check. And that's correct. Wait, no, that's not correct. Hold on, just a minute now. Okay, a sign error. Okay. Good, I'm glad that was caught. All right. Problem 12. Right, so we have the function z of t, which is the square root of all of 3t minus 4. And we need to determine if it's increasing or decreasing at these given points. So we need to find z prime of t. How to do that? Well, they haven't actually given us the technology of the chain rule yet, right? So are we supposed to just use the definition of the derivative at this point? No, you know what? Let's think critically instead of mechanically. Yeah? So this is a square root function. And what happens if I multiply the argument of a square root function by 3? Well, it stretches horizontally by 3. Okay, what happens if I subtract something from t? Like, what happens if I subtract 4 over 3? Which is what's happening in this case, by the way. Let's write this down. Like, z of t in reality is this, isn't it? Okay, what does this do to my function, my square root function? It translates it to the right by 4 over 3, 4/3. So we know that the square root function looks like this, half of a parabola. And all I've done is stretched it horizontally and then translated it by that amount. So it's going to always be increasing, isn't it? Right? That's quite logical, isn't it? And we better make sure that it's actually defined at all these points, and it is. So it will be increasing at all points. So we don't have to use the chain rule or anything. We can just think about what it looks like. Let's see if he has the same notion. I guess not. But whatever. All right, so problem 13. Suppose that the volume of water in a tank for 0 to 6 seconds, minutes, who knows, is given by this. Q of t is 10 add 5t, take 2t, take t squared. Is the volume of water increasing or decreasing at t equals 0? So I think this is just simple differentiation. So we find q prime of t. Negative 2t plus 5. Then q prime of 0, which is 5. So it's increasing as q prime of 0 is greater than 0. Q prime of 6 is negative 12 add 5, which is negative 7. So it's decreasing as q prime of 6 is less than 0. Does the volume of water ever stop changing? If yes, at what times does the volume stop changing? So we have to solve this. And of course, this is just 5 over 2, or 2.5. And that's the answer, I think. Okay, they agree, and they agree. All right. So that's the interpretation of the derivative solved. That portion anyway. So I'm going to save this and then move on to the next section. All right. What's the next section though? Differentiation formulas. Differentiation formulas. Okay, so it's not raining and that's good. Let's just get on with it. Find the derivative of the given function. So these are all just polynomials, so it's straightforward. So no mistakes. Guess we can just alternate notation for them. So I guess I wonder how they would like it. So we'll check these 5. Correct. 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 So first, we will write f of x in this sort of pseudo-polynomial way as 10x to the 3/5 minus x to the 7/2 plus 6x to the 8/3 minus 3. Then we'll differentiate it. So we get 30 over 5, which is 6. So 6x to the minus 2/5, and then minus 7/2x to the 5/2, and then 48/3, which is 16. So 16x to the 5/3, and the constant disappears. Same technique for 7, problem 7. F of t is 4t to the negative 1 minus 1/6 of t to the minus 3 plus 8t to the minus 5. And so f prime of t is negative 4t to the negative 2 plus a half t to the negative 4 minus 40t to the negative 6. Problem 8, rewriting r of z as 6 Problem 9.
Not that long, but oh, what are you doing up here?
Let's see. Right, so we'll just expand it out. And checking 5 to 10, or 6 to 10 rather. 6, 7, 8, 9, 10. Good, good, and good. Correct, correct, and correct. All right, that's correct. Problem 8. Correct, correct, correct. Okay, that's fine. dz by dx. Okay, that's fine there. And that's fine as well. Okay, for the 11th one. Okay, 11 and 12. First, we declare that h of x is 4x squared minus 7 plus 8x to the minus 1, dividing each by x. And then h prime of x is 8x. That 7 shall disappear. That negative 7 shall disappear as a constant. Then we have negative 8x to the negative 2. Then, in problem 12, f of y, dividing through y to the 5 over y cubed, that's y squared, minus 5y cubed over y cubed, that's minus 5. 2y over y cubed, 2y to the minus 2. And so f prime of y is 2y, that constant disappears, minus 4y to the minus 3. Check these. That's correct. That's correct. Right, 13th problem. Determine where, if anywhere, the function f of x is not changing. First, we find the derivative, which is 3x squared plus 18x minus 48. Then we solve for where the derivative is equal to 0. That's where the function is not changing. Everything is divisible by 3 here, so we divide through by 3. This can be factored. So not changing. That's where. See if that's correct. And it is. Good. 14th now. Okay, we have to find the derivative first. So we're going to say dy by dz 8z cubed minus 3z squared minus 6z. Then we solve it. We find out where dy by dz equals 0. So 8z cubed minus 3z squared minus 6z equals 0. Solving this, we can factor out z immediately, and then that leaves us with a quadratic. But can that quadratic be factored? We can apply the discriminant, b squared minus 4ac. So our a, b, and c are 8, -3, and -6. Putting them in, we get the square of -3, which is 9. Minus times a minus, okay, that will make a plus. And then 4 times 48. So that's 192, I think. 192, which is 201, which is not a square, so it can't be factored, I believe. Cannot be factored. So using QF, the quadratic formula, hold on a second, 201, well, that's 3 times 67, and they're both primes. All right, so fine. So z equals 0, or extracting the components now and putting them into minus b plus or minus the square root of b squared minus 4ac all over 2a. So 3 plus or minus, already found this out, all over 2 times 8, so 16. So that's what I believe the answer is, but we'll see. Oh no, wait. Uh-oh. Oh my goodness me. Wait, am I looking at the wrong thing? Am I hallucinating? What on earth? Oh no, wait. I get it. I differentiated it, and I'm looking at the base function. Okay, great. Okay, so fine. Okay, wonderful. That's actually true. Fifteenth problem. Continue. find the tangent line to g of x equals 16 over that thing at x equals 4. Okay, first put it in the pseudo polynomial format like that and that. Then find g prime of x like that and that. Then find g of 4 and g prime of 4. So g of 4, that would be, let's see, we've got a 4 there. We have to take away 8. 4 take 8 is minus 4. Then here, g prime of 4. Okay, that'll give me minus 1 right there for the first term. And then square root of 4, which is 2, but the reciprocal of that, please, which is a half. And what's minus 2 times a half? That would be minus 1. So we get minus 2. Now, use this formula here, y minus y1 equals m open brackets x minus x1. Because we have the ingredients, we have the m, the gradient of our tangent line, and we have the point that we need, which is, wait, where did I put that? Right, okay, let's spell it out entirely. Grab all of this, yeah? Okay, so we know for the tangent line, m equals negative 4. Wait, am I doing? No, I would have done it wrong if I did that. Okay, m equals negative 2. M equals negative 2 from the derivative. And we know that, what do we know? We know that 4 comma negative 4 lies on it. We know those two facts. And so now we're going to use that formula right there to figure out what this tangent line actually is. So y minus y1, so I just write y plus 4. And then I put a negative 2 right there, and then x minus 4. And then simply rearrange. So minus 2x plus 4. And I think that's the answer. And that is great. Great. Okay. 16th problem. Okay, it's basically the same. I noticed that they're coming in pairs. They're sort of coming in pairs, these problems. All right, so what do we do? Okay, f prime of x first. Let's find that. Okay, so that would be 28 x cubed minus 48 x to the minus 7 plus 2. Now, first find f of negative 1, and then find f prime of negative 1. So when we do f of negative 1, let's see, what's the fourth power of negative 1? Well, that would be 1. So that turns into a 7 right there. What's negative 1 raised to the negative 6? that would be 1 over negative 1 to the 6. So that is also 1. So that turns into an 8. So 7 plus 8. And then finally here, this is simple. So it's 7 plus 8 minus 2, which is 13. So that means that minus 1 comma 13 is on it, the tangent line. And now f prime of negative 1, put negative 1 into here. So when you raise negative 1 to an odd power, you get negative 1. So this would be negative 28 plus 48, which is 20, and then add 2, so we get 22. Now, by the same formula from before, y minus y1 equals m, open brackets, x minus x1. So we're going to have y minus 13 equals 22 times x minus minus 1, so plus 1. Last step now, y is equal to 22x, and then we have a 22 there, and we have to add 13 to it, so we get 35. And that should be right. That should be right. And there you go. It's correct. Okay. 17. The halogens. The position of an object at any time t is given by this formula right here. Determine the velocity of the object at any time t. The derivative of this displacement function with respect to t will be the velocity function. So you just find the derivative. So it's 12t cubed minus 120t squared plus 252t, and that's it. Does the object ever stop moving? So set the velocity function here, set it equal to 0, and solve. First, notice that everything can be divided through by 12. That's 21. Then notice that this is actually factorable. So we have t minus 3 and t minus 7, just there like that. So t equals 0, 3, and 7, the object is not moving. When is the object moving to the right, and when is it moving to the left? So we'll take positive velocity as moving to the right. Now, all right, so this is a cubic. So when is the cubic positive? That's the real question. And so we visualize the cubic on the graph like that. There's the velocity function of it. And it passes through 0, 3, and 7. And so it does this, like that, something like that. And so when is it positive? The answer is here and here. And so, what do we say? We say for t between 0 and 3 and t greater than 7. But we have to be careful about how strict our inequalities are. And the answer is that you exclude the endpoints. So what can we say here? Like that. And I think that's the answer. Okay. Right, so they just factored it for some reason. For later, I guess. And then that's correct. And there it's moving to the right. Yes, that's true. Okay, good. Problem 18. Determine where the function h of z is increasing and decreasing. Okay, so let's find h prime of z first. And let's do it in descending powers of z. So we're going to have negative 20 z to the 4, negative 20 z cubed, plus 80 z squared, and the constant on the end disappears. So we can factor out 20z, right? Let's just do negative 20z and just see this. So I'll have z squared minus z plus 4, like that. And you can't factor this. Oh, really? Did I do it wrong? Minus 20, minus 20. That should be 120. Okay, so I did it wrong. And okay, so that would turn into a 6 now. And so now I can do it. Oh, what? No, I still can't. Okay. That was kind of Right, okay, but notice from the discriminant that b squared minus 4ac, notice that it's greater than 0, so that quadratic is actually like above the z-axis, isn't it? Okay, so anyway, what actually is it that we're trying to solve here? Let's just be clear. So we want to know about the sign of h prime of z. So it's a negative quartic. So you can think of an upside down negative U, like an upside down U shape, sort of, or W shape, potentially. But then the question is, does it have any roots? And yes, it must do. It must have a root of 0. But what do we do about this? Uh-oh, I don't know. For some reason. Okay, let me think. Well, first of all, this is wrong because that should be squared. And that doesn't have any solutions, does it? Unless I did that wrong. And I did do that wrong. So there you go. It's another error. Another error. Goodness me. It's just everywhere. Just absolutely everywhere. Okay, so minus 20. That turns positive. That turns positive. That turns negative. There you go. Okay, now. That's good. So z add 3 and z minus 2. Okay, this is great. Because now we know that it has 3 roots. This one has a multiplicity of 2, so it's just going to touch it. And this quartic is going to look like this, isn't it? There. Negative 3, like there. And 2, like there-ish. And it's going to look like McDonald's. Like that. Although it won't have that kind of cusp. It'll be like there, like that. And so now we can say something. It is decreasing for z, which is less than negative 3, and z, which is greater than 2, and increasing for z trapped here and z trapped here. Okay, now I have to see if any of that is right. Okay, so I got there eventually. There it was. And yes, I agree. That's correct. Okay, 19th problem. Determine where this function is increasing or decreasing. It's already factored, but can I use that to help me or not? Let me just think about that instead of cubic. Right, so unfortunately, that's not actually going to help me a whole bunch. I can say it's increasing for this much and for this much and decreasing for this much. I actually don't know where that point is, do I? So, looks like I'm going to have to expand you. Okay, x plus 1 times x squared minus 4x plus 4. And expand out, x cubed minus 4x squared plus 4x, then plus x squared minus 4x plus 4, and put it together, x cubed minus 3x squared, cancel, plus 4 there. And r prime of x is 3x squared minus 6x. So, to solve this, and we do, so the points that we care about are think 0 and 2. All right, so that's actually okay. That's not actually bad. Decreasing for that. I wonder if that's true. Oh, yay! I'm getting better at this. Okay. Determine where, if anywhere, the tangent line to that cubic right there is parallel to that line there. So, find f prime of x. That's what I'm going to do. 3x squared minus 10x plus 1. And I'm going to set it equal to 4. Oh, goodness me. Really? Is that really, really, really the case? Darn. Really hope I did an arithmetic error. 3x squared minus 10x plus 1. No, I think that's fine. And I think that you actually do have to set it equal to 4. And when you take away 4 from both sides, you actually do get this. And you actually can't factor this. But it looks so close. Sorry. Doesn't work. Doesn't work. In fact, you don't even know if you can solve this. Okay, so by discriminant, I get 100. And then there I get 9. So 136, which is not a square. But 136 is square-ish, isn't it? Well, 136. That's, what is that? Come on, make a move. It is 34 times 4, so it's 2 root 17. All right. So, by QF, quadratic formula. I just worked this out, but yes. Which is root 136. So that's 78. That's 39, isn't it? 39. 39. It's 39. All right. So at x equals 5 over 3, 5/3 plus root 39 and 5/3 take root 39. So I think oh man, why does it plague me so? B squared is 100. Because that's not correct. That's why it's 30. Right. 136. What is half of that? 68. What's half of that? 34. Thank you. Man. Some days I can juggle numbers, and other days I can't do anything with them. It's kind of scary when that happens. It's like just someday not being able to spell words or something for no reason at all. All right, so differentiation formulas. You are finished. And who's next? After this, product rule and quotient rule. I can't wait, but I have to for health. Be well.